All right, folks, I think we'll go ahead and get started, and folks can join in as we begin. Welcome to the first webinar of our Integrated Water Management webinar series. My name is Melissa Soline. I'm a program manager with the Great Lakes and St. Lawrence Cities Initiative. I've also got with me Laura from our Chicago office. You heard her speak first, handling the webinar from the technical perspective for us. I'm excited to get started on our webinar today, but I just wanted to do a bit of housekeeping up front. At this point, everybody that's logged in should see an agenda for our call today up on your screen, as well as a dashboard on the right-hand side of your screen. All lines are going to be muted during presentations, and we'll hold questions till the end of all the presentations. We've got a 10-minute question period at the end of the webinar for folks. Certainly, though, if you've got questions as presentations are going on, you can type them in the chat box that you'll find on your dashboard. And then during the question period, Laura will field those questions and read them out loud for panelists and to answer. The other option during the question period would be for you to raise your hand, which would simply be clicking the hand icon on your dashboard. And then at the appropriate time, Laura will unmute your line so you can ask your question. If you happen to have any technical issues during the webinar, I've listed my email address at the bottom of the agenda. Please feel free to shoot me an email. I'll monitor my email and see if I can't help you out during the webinar. And last but not least, just a note that this webinar is being recorded. We'll be able to post an archive of the webinar on our website and on the Greater Lakes project website as well. Got a few more people trickling in, I think. But with that, I'd just like to welcome everyone today. This webinar series actually grew out of work we're doing with the Great Lakes Commission project funded by the Great Lakes Protection Fund. And the project is called Greater Lakes, Reconnecting the Great Lakes Water Cycle. John Jackson, the project manager, will be providing a background on that project. But I just wanted to say that the concept of integrated water management, which we're going to delve into a bit today, resonates in much of the work that we have underway through our Green Cities program, through our sustainable municipal water management effort, our municipal adaptation and resiliency service work, and our water conservation framework. So I was very excited to work with John and the Great Lakes Commission to put together a webinar series that explores this concept of integrated water management for municipalities from a few angles, with the ultimate goal of trying to just help move the bar forward, get a better understanding of what some of the challenges are that cities are facing with, trying to do integrated water management, figuring out how water conservation and green infrastructure play a role, and then just trying to find some more practical tools and resources that cities can use to get started. But today we're starting from the beginning, and we're going to explore this concept of integrated water management within the concept of the Greater Lakes project. First, we're going to hear from John Jackson, the project manager. He'll give some background. And then we'll hear from project partners Bill Christensen from the Alliance for Water Efficiency and Jim Ridgway from ECT. So with that, I'm going to turn it over to John to provide some background.
Okay, thank you, Melissa. I'm really pleased to be working jointly with you people on this, and the Cities Initiative has been part of our project from its beginning 2 years ago as in an advisory role, and it's made a lot of input into the directions that we've been taking. What you're going to be hearing today is a lot of the findings from the past 2 years. Our project is now 2 years old, and you'll be hearing the main findings. Obviously, there are a lot of other findings, but this is the main part of it. Go to the next slide, please. We have 3 project goals in this project, and the first one is to get a better understanding of both the environmental and the financial implications of water conservation and green infrastructure projects. Because our work is focused on municipalities, on municipal audience, and it's clearly essential in terms of municipalities making their decisions, both in financial and environmental aspects must be taken into account in a high way. We are working in 6 municipalities. I'll list those for you in a minute. In 6 municipalities, but we look at those 6 municipalities only as examples for us to learn from to share with other municipalities. Our goal is to be helping municipalities all across the Great Lakes and St. Lawrence system to be doing a better job in terms of moving towards integrated water management. And central to that, of course, is our third aspect is finding what are the most effective ways to get the messages out. And so we're exploring that through various knowledge transfer techniques. Next slide, please. On the Ontario side, we are looking at 3 municipalities, have been working closely with 3 municipalities, and these are in the Grand River watershed, which is the largest watershed in southern Ontario, and it flows out into Lake Erie. The 3 municipalities we've been working with are the city of Guelph, the region of Waterloo, which includes in it Waterloo, Kitchener, Cambridge, those cities, as well as the surrounding townships, as well as the city of Waterloo that we've been working with. So the next slide, please. This is a bi-national project, and that's at the core of all of our work, as we know it is for the Cities Initiative, and so that's why we're really pleased to be working with you people. So we also are working in 3 municipalities in Michigan, and these are 3 municipalities in Oakland County, just north of Detroit. The 3 townships are Lyon Township, Commerce Township, and Oakland Township, and you'll be hearing more about all of those municipalities as you hear from Bill and from Jim. Next slide, please. Our project partners in this project are the Great Lakes Commission, which is the home base of the project, and I'm working as a project manager and as a consultant to Great Lakes Commission on this project. Our other 2 technical partners are the Alliance for Water Efficiency, and you'll be hearing from Bill right away, and he'll quickly describe that. You'll see his work. Our other partner, our other technical partner, is Environmental Consulting and Technology, Inc., and you'll be hearing from Jim on that, and he'll describe them a bit as well. So the next slide. So in addition to those technical partners and the municipalities that we're working with, we also have an advisory committee, and it's made up of conservation authorities, which are unique to Ontario and are an important part of the municipal role in Ontario. Other municipalities are on the advisory committee, as well as some not-for-profit organizations. And this advisory committee has been playing a really essential role in helping define the direction of the project and the principles underlying the project. This picture was taken at a joint meeting of the advisors and the partners that we held in Oakland Township, in Oakland County actually, last July. Next slide. So the premises underlying this project are, first of all, that we have a fractured water system that disrupts natural water flows. And that's having negative impacts both environmentally, but also it's having negative impacts in terms of financial costs. And you'll be hearing much more detail about that. Jim in particular will be speaking to that later. And we believe that it's essential to get to an integrated water management system where our decision-making around water supply, around stormwater, and around wastewater, we're looking at them all at once to make sure that we're taking into account how they can support each other and how they can avoid disrupting each other. Next slide, please. The other premises that we're working on is that if we want to restore this more natural water system and integrate it properly, we need to put much more focus on water conservation and efficiency and on the role of green infrastructure. And these need to play much more central roles than they have traditionally in the way in which we've designed our infrastructure. And then also we need to be having both a short and a long-term perspective. Often if we look at the cost, for example, of implementing something and look at it only in the short term, it may not seem to financially make sense. But if we're looking at long-term costs, what does it mean for our future costs in terms of infrastructure expansion we might have to do, for example? It may well make a lot of sense to be getting into it now and to repeat, combining both environmental and financial perspectives. Next slide. And finally, we just want to stress that we know that not all municipalities are the same. We know that one size does not fit all, but we also know that there are valuable lessons that we can learn from municipalities, and that's why our focus on the 6 municipalities, but we're taking the lessons from that to spread throughout the entire basin. And finally, on the last slide, is we always, of course, have to thank our funder, the Great Lakes Protection Fund, and we particularly appreciate in this case that their funding all comes from state governments, grants that were made to the state, to the fund many years ago, and they live on the earnings from that money. But they have funded this as a bi-national project, really seeing the need to work in both Canada and the U.S. together. So I'll turn it over now to Bill Christensen to get into the more detailed presentation.
Thanks, John. Okay, as Laura's switching over to Bill's slides, again, we're welcoming Bill Christensen with the Alliance for Water Efficiency. And I apologize to folks if you keep hearing, it just happened, that ding. I don't know if you guys are hearing that. We're trying to figure out how to, that's people entering the webinar. So, Bill, over to you.
All right, thank you, Melissa. My name is Bill Christensen, and I work with the Alliance for Water Efficiency. And we're a North American nonprofit organization dedicated to the efficient and sustainable use of water. We're based out of Chicago, Illinois, and we were very happy to be a partner on this project. And our role was to conduct a cost-benefit analysis of water efficiency programs. So I'm going to take you through what we did and what we learned from our analysis. In conducting the analysis, we used the Alliance for Water Efficiency's tracking tool, which is a model that's available to our membership for free that can be used to assess the costs and benefits of efficiency programs. And down in the lower right-hand corner is a screen capture of that model to kind of put a face to the name. So what goes into the model and what comes out of it is what I'd like to talk about on this slide. And so we look at things like demographic data, weather data such as precipitation and evapotranspiration, and we enter things like customer utility rates, so how much they pay for water, sewer, electric, and gas. And then we enter water demand forecasts, so what the current water demand is and what it's expected to be out into the future. And then we include things like avoided costs. And an avoided cost could be something like wholesale water purchase costs. So if a utility purchases wholesale water and they have an efficiency program, they may have to purchase less of that water in the future, and therefore they're avoiding one of their costs. Another avoided cost could be avoiding a large expansion so that a water utility can produce and deliver more water in the future. Oftentimes, water efficiency programs lower demand and then lower the need for expansion, thus saving utility millions of dollars in the process. And next, the user enters all the information about an efficiency or conservation program that they want to look at, things like the cost of the program and the expected savings of those programs. And then last but not least, the model has a greenhouse gas module. And for the inputs, the user enters the embedded energy in water that they deliver. And if they don't know that value, the model contains a built-in calculator that will allow an estimate to be generated for how much energy is embedded in water that's delivered. And then out of that, we get predicted water savings, the costs and the benefits of individual water efficiency measures and as a whole, and then a look at the impact to revenue and rates through the reductions in demand, and then we get those greenhouse gas emission reductions and energy reductions resulting from efficiency programs. So I don't need to spend too much time on this slide because John mentioned the 6 communities we looked at. We had 3 in Ontario and 3 in Oakland County, Michigan. But I did want to show this slide, which is a visual representation of the communities. So on the left, we have the city of Waterloo, and you can see it's pretty urban. And then on the right, we have southwest Oakland, which is not as dense, not as urban. We see a lot of neighborhoods. It's very residential. So what would that do, or how would they differ in terms of water use based on just looking at these pictures? Well, we can look at how the customer class demand shares are broken out, and we see that in the region of Waterloo, where we saw that picture where it's more urban, that there's more commercial water use. So if you look at the green part of the pie, you can see that commercial water use makes up 26% of water demand in that service area, whereas over in southwest Oakland, one of the Michigan communities, only 3% of the overall demand is commercial. And we see 81% of the demand is residential, whereas over in region of Waterloo, it's split out between single family and multifamily, making the residential a little over 60%. So quite a bit of a difference in terms of the communities. And that was really good for the analysis because it's nice to look at communities that have different characteristics. So we looked at some indoor water efficiency programs, quite a few, and that included things like toilet replacements, toilet flapper replacements, which are a part of a toilet that need to be replaced from time to time because if they're not replaced, the toilet can leak, and leaks waste a lot of water. We looked at clothes washers, hot water recirculation systems. Those are things that reduce the wait time for hot water. So in the morning when you're waiting for your shower to warm up, if you had a hot water recirculation system, you wouldn't have to wait nearly as long as if you didn't have one. We looked at new home specifications, so efficiency requirements for new homes. We looked at gray water systems and pre-rinse spray valves, which if you're not familiar with those, they're used in commercial kitchens. They're valves that are used to rinse off plates before they go into a dishwasher. And we looked at restaurant certification programs that would work with restaurants and incorporate efficiency and provide incentives for efficiency improvements. And then we looked at a capacity buyback program in which the utility works with commercial or industrial customers and assesses how much water can be saved, and they provide incentives based on how much water can be saved for specific measures. And we also looked at cooling towers and then two programs, site visits and education, that really get out there and work with the customers. We also looked at outdoor water efficiency programs, and these included landscape surveys, which would involve the utility going out and working with an individual customer and surveying their property and seeing what improvements could be made, as well as irrigation controllers, such as weather-based controllers, soil moisture sensors, and we also looked at efficient sprinkler nozzles as an option, and then rainwater harvesting. So what did we find? On this screen, you see a table that shows the region of Waterloo's costs and benefits output sheet. And the activities are on the left, and then the next column is the cost, and the PV stands for present value. So all the dollars in the model are expressed in a single year, and so these are all in 2014 dollars because the analysis was done in 2014. And then so you have the cost and the benefit, and then the value, which is essentially the benefit minus the cost, and then a benefit-cost ratio. And you want a benefit-cost ratio greater than 1. And you can see in instances where it's not greater than 1 that the text is red. And this indicates that the cost outweighs the benefit. So some of the benefits are avoided supply costs, avoided wastewater treatment costs, and in the case of expanding capacity, those types of benefits. And the other costs that go into the program could be staff time, if you're providing a rebate or other type of incentive, costs for marketing, and any other overhead. So we had a really good mix in Waterloo, and a lot of them proved to be cost effective. And this shows the output sheet for Guelph. And again, we see a different mix of programs. We see the majority of them are cost effective. And what's really interesting is that the tracking tool gives you an output for the total of all the measures. So in this case, there are some measures that are not cost effective that I'm highlighting now, such as the healthy landscape visit. However, the utility may say, overall the efficiency programs are cost effective because you're given this total number, and you may choose to include something like a landscape visit because it gives you contact with your customers and raises awareness and provides education. And I wanted to show the energy reduction benefit. In the next slide, I'll look at greenhouse gas reductions, but this is in Guelph, and this chart shows the energy reductions from the programs as well as savings from natural replacement of fixtures. So the marketplace has become a lot more efficient over time, and we see a lot of efficiency or conservation just happening naturally when people replace things like toilets in their homes, because when they go to the store, there's really only efficient options in the marketplace typically. So the purple bar shows savings on the customer side for electricity based on the programs. And the green part of the bar shows the passive savings, or those savings I was just talking about when people naturally replace things, that there is some electricity benefit there. And that could be, for water heating, or in the case of a clothes washer, using less electricity. And then the red portion of these bars shows the utility electricity savings based on the programs. And then the blue part shows how a utility might save electricity naturally when their customers replace their fixtures naturally. And next we have the greenhouse gas reduction benefit. And this chart shows the cumulative carbon dioxide emission reductions over time. And again, this is for Guelph. And we can see by 2035 that they've saved almost 70,000 metric tons of CO2. So a very meaningful reduction through efficiency programs. And so now I clicked over to the Oakland County costs and benefits. And there are 3 communities here. We have Commerce Township, Lyon Township, and Southwest Oakland on the far right. And you see a lot of red on this worksheet. And it's quite interesting that Commerce, we found everything we tried looked to be cost effective, but in Lyon and Southwest Oakland, only the high efficiency toilet rebates look to be cost effective. And this is because Commerce Township purchases its water from Detroit and has higher costs that they can avoid with efficiency, whereas Lyon and Southwest Oakland have local water supplies and are quite inexpensive in comparison to Commerce to operate. So another interesting thing about these 3 communities is that their housing stock is all relatively new. And in the United States, we have the Energy Policy Act of 1992, which went into effect in 1994. And it required efficient fixtures. And one example of that is after 1994, all toilets in the United States could have a maximum flush volume of 1.6 gallons. And before that, it was 3.5 gallons. So we saw a lot of reductions in water use because of that. But in a service area like these where they're very new, there's not as much opportunity for replacing toilets and other fixtures in homes. So because of that, we looked at a lot of outdoor programs. And another reason we looked at outdoor programs is we saw a very high peak season water use in these 3 communities. And this was one of the most interesting findings in our study, is that here, in a humid climate, we're seeing a lot of outdoor water use in the summer, and it's predominantly used to water lawns. If you remember that picture I showed way back of the 2 communities, there was a lot of green space, and a lot of that's being irrigated. So this chart shows the peak season water use for each of these 3 communities. And the first quarter and the fourth quarter that are shown are the winter months, and the 2 middle months are the summer months. And you can see how water use just peaks for those time periods. And in Lyon Township, they use almost 2.5 times more water in the summer. In Southwest Oakland, we saw what's being called in this chart a peaking factor of over 3 times. So they're using more than 3 times the amount of water in the summer versus winter.
Bill, sorry, you have 5 minutes.
All right, thank you. So planning outdoor programs is a bit more tricky than an indoor program. Indoor programs are a bit more predictable in terms of the savings you'll get. But with outdoor, people use water differently from household to household, and it's just harder to predict. So we did some digging and came up with components of successful outdoor water efficiency programs. And so these are some of the things that would help a program be effective, and that includes targeting high water users, educating contractors and customers about outdoor water use, and then following up if you do have any programs and assess to see if water savings are being realized, but also follow up to make sure the equipment is programmed and functioning properly. So you may provide someone with a rebate or a free irrigation controller, but then when you walk away, it might be programmed improperly or turned off altogether. And for programs that are going to focus on not replacing turf, but just improving the efficiency of irrigating turf, it's very important that turf quality be maintained. And then last, because these programs are a bit tricky, it might be a good idea to pilot small-scale programs, and then you can find out what options, what technologies would work well in a specific service area. And we noticed, in Lyon Township and Southwest Oakland, that a lot of the programs we looked at were not penciling out to be cost-effective. So we wanted to also provide some other options for reducing demand. And those can involve rates, so you could have an inclining block rate structure or a seasonal rate structure, requirements for new construction that have efficiency requirements for indoor and outdoor water use, watering restrictions, increased education and outreach, water loss control. However, in these communities, in all of the communities we looked at, their water loss was pretty minimal, so not a huge issue. And then there's professional training and development options, such as Irrigation Association certification or the Qualified Water Efficient Landscaper training. So I have 2 more slides to cover the lessons learned. And as John touched on already, every service area is unique, and what works in one community may not work in another. But that also means what doesn't work in one community could work in another. We also found that water providers with a long history of conservation can still find cost-effective opportunities, which to me was one of the most exciting pieces. In Ontario, those communities have been at it since the 90s. They've been really active with efficiency and conservation. So to see that there are still a lot of opportunities was great. High peak water use can be an issue even here in the Great Lakes. So as we move forward and look for opportunities, we should look at outdoor water use and help bring down that peak. Gray water and rainwater harvesting programs did not appear to be cost effective in Ontario. And this is important because these are gaining a lot of interest, and that's not to say they won't be cost effective someday or in some service area, but when we looked at it, they were not. And as I mentioned, communities with new housing have less of an opportunity for indoor programs. And the low avoided costs that we found in some communities made it very challenging to plan cost-effective efficiency programs. However, those costs may change over time. And one way that could change is if a community was facing an expensive infrastructure expansion project that could be avoided or downsized with efficiency. And then in Lyon Township and Southwest Oakland, if they're ever faced with purchasing water from Detroit, as does Commerce, then their avoided costs would go up, and we would see their efficiency programs that we looked at become cost effective. And then strategies such as ordinances, education, training, and water rate design can also play a role in reducing demand. And then last but certainly not least is that water conservation programs provide a meaningful energy reduction and greenhouse gas emission reduction. So that wraps up my presentation, and thank you everyone for listening.
Thanks so much, Bill. As we switch slides over to Jim, I'd like to introduce our next speaker, Jim Ridgway with ECT. Jim's going to be discussing his analysis on the impacts of water conservation and stormwater management in the 6 pilot communities. And it looks like we're just getting you up right now, Jim. I'll turn it over to you.
Hi, I am Jim Ridgway. Can you hear me? Can you see me?
We can hear you loud and clear.
Oh, great. Let me begin by saying nothing I'm about to show you is rocket science. This is common sense 101, but just as Bill said, a lot of our worst practices are baked into codes and fees and things that we didn't think about real well a long time ago, but we get smarter every day. Say a little bit, I work for Environmental Consulting and Technology. We are lucky that we have a very strong water resources practice. We've done quite a little work with the Great Lakes Commission and the Great Lakes and St. Lawrence Seaway Cities initiative. But we also do an awful lot of work for municipalities. And if nothing else has become clear to us is the municipalities are under tremendous financial pressure. They've got to learn how to do things smarter. So in the municipalities that we've worked with around the Great Lakes and along the eastern part of the United States, their problems are very consistent. The codes and practices that I will talk about mostly have been written by engineers. ECT has this bench full of, I call them the gists, the ecologists, the arborists, the biologists, and people that look at the problem differently than hardcore civil engineers do. So the solutions that we have are common sense. They've been around for a long time, and it should not be difficult for us to, didn't move. Oh, good. It shouldn't be difficult to retrain not only the general public, but even our elected officials. Everyone has seen a picture of sort of the hydrologic cycle. We understand things rain, snow, and sometimes it sinks in the water, and if it comes too fast, it runs downhill, typically into a river. But we also have to think about sort of the bigger picture, and that is that I'm sitting in a place right now that we get about 32 inches of rain. And we get, if your bird feeder had big enough walls around it, you would find that it would gain water over the year because a certain amount of water shows up and a certain amount evaporates, pan evaporation. That's different than evapotranspiration, and that's all the water that leaves through the plants or helps the plants grow. So when you look at a tree, you have to realize, or a blade of grass for that matter, you have to realize that that tree was made of carbon out of carbon dioxide in the air, kind of glued together with some hydrogen that was once water, and it released a bunch of oxygen, both from the CO2 and the H2O. And that makes trees and grass and that sort of thing. When we cover it with concrete, that source of storing water goes away. So if you look at the water cycle, we basically have, water runs downhill, some sinks into the ground, some does not sink into the ground. Our historic engineering practices have said, you know, if it stays here too long, we get local flooding. Local flooding is bad. I agree with that. And so the solution was to take it downstream as fast as you can. We did that, and we built a lot of concrete. That, of course, caused downstream flooding. We did some other things that prevented downstream flooding by putting some measures of storage, also typically with concrete or engineered solutions. And both of those had the impact of diminishing groundwater, which in the long run is not bad. So we don't want to shortcut the hydraulic or hydrologic cycle if we can get away with it. And our codes and our fees have been causing us to continue to do that. But what have we done? Well, yes, flooding and drainage has to be managed, and we have to prioritize how we use our resources. Flooding is bad. You'll get sued instantly with that. And so most public works types, the conservative public works types, want to, number one, prevent flooding. And so they build these very large structures. And I am not for a minute saying we don't need a certain amount of gray infrastructure. But I am saying with the addition of things like green infrastructure, you can lower the cost of these things, both in the short term and long term. And excess peak flows cause you to build giant facilities. This happens to be a combined sewer overflow facility being built. And it is not there because there's too much sewage. It is there because we get too much rainwater where we don't want it, and we end up throwing civil works at it. Our communities have figured out we have to be smarter. In the olden days, they would wait till a sewer would break and then fix it, very costly. Nowadays, they're doing a much better job of doing preventative maintenance, asset management, those sorts of things in an effort to control their costs. But being a little bit more predictive and a little bit smarter, they could realize that capturing water where it falls, managing it as it goes downhill, and managing it as it is discharged will save you money. We've got a lot more sophisticated tools. We've got a lot better idea of how to do these things, but unfortunately, many of our building codes, drainage codes, stormwater fees are in support of the old-fashioned way of building green infrastructure. Oddly, private industry has sort of led the way in what we now call green infrastructure. And they haven't done it solely because it's pretty and they're on the side of the angels. They've done it because it is a lower cost solution in many ways. And so if you look at a lot of things that are done in industrial settings or administrative settings, they've been around for a very long time, and the tools to support them have been around for a very long time. So you can look at any of these, and just as Bill did earlier with the water use, you can predict how much energy is saved, how much carbon is captured, and those sorts of things, but on a much smaller scale. So if you want to figure out what factors dictate how the water use is impacted, you need to look at the local hydrology and what we've chosen to do. I like to show this picture. This picture here is in Dearborn, Michigan. That bridge in the background is a very famous bridge where on the right-hand side is Ford Rouge plant, and the unions had a big fight there, you know, when they first were established. That was kind of a big deal. But even a bigger deal, at least more locally, is we were able to convince the road people to take 2 lanes of traffic out that had been underused for decades and manage their stormwater in an area that this is a heavy industry, so that the road runoff was very dirty, and the road guys, being the conservative guys that they are, hate doing this sort of thing. But if you go to the Wayne County Road group now, they would tell you that this is a success. So I would argue that we need to manage how we manage stormwater in developing areas, but we also have to revisit in the fully developed areas and look for opportunities where we can manage both the volume and the quality smarter. Sometimes There it goes. So the different sources have, we try to feed our groundwater. The groundwater does lots of very good things for the environment and for river flows. It is the slow, constant feeding of the small streams and rivers that support biota and fish and all of those things. And when we manage stormwater poorly, we sort of mainline it into the Great Lakes. So a Great Lakes supply volume is fine, but unfortunately we have washed lots of bad things into the Great Lakes when we shortcut it. But as a water supply, when we shortcut the groundwater and we begin to diminish the volume of the groundwater, that ends up not only affecting the availability of water, but it also will impact future development. So groundwater sources need to be protected, as all sources do, but you recognize that not only water quality is an issue, but water quantity is an issue. Urbanization is in many ways the sin. I mean, we all choose to live in urban, or most choose to live in urbanized areas, and we all need our roads, but impervious surfaces, when managed, I'll say traditionally, are one of the largest loads to the Great Lakes for all kinds of things we don't want in the Great Lakes. Not only does it wash debris, but it also, everything from asbestos to lead to things that fall off your car. And it doesn't take a lot to show that with a little bit of infiltration, a little bit of slowing down, that water quality improves a lot. That initial research was done 40 years ago in Washington State, yet we still have codes that are mostly flooding related, that are trying to get water off the roads as fast as you can. That's important for safety, but also down the ditch and or pipe as fast as it can to prevent flooding. I say again, flooding is bad. We cannot allow it to impact the safety or values of our property, but green infrastructure can be managed so that you don't have a flooding issue, but you are increasing infiltration. That also prevents combined sewer overflows, temperature increases, lots of environmental things that other folks have worried about. And it's a big number. It is a big, big, big number. This happens to just show what a calculation for a 1 mile road would be for a 1-inch rain. But I remind you that, at least where I'm sitting, I get about 32 inches of rain. So it is very large numbers that are bringing contaminated stormwater to rivers and prevents very large amounts of water from getting into our groundwater. There are many examples where just a little bit of change can change how much water infiltrates. This happens to be a newly developed subdivision in Bloomfield Hills, Michigan, and it is designed not with curb and gutter, not with ditches, but with managed drainage. Now, these sorts of practices may not benefit a giant highway, but there is an awful lot of small, either developing or developed communities where better management of stormwater will provide not only higher quality environment, higher quality water, but also an improved quality of life. If you take a road and you look at some of the communities we worked in, you can see that there are a lot of miles of road, and so that these numbers get very, very large. And once again, these numbers are all with 1 inch of rainfall, so if you multiply them by 30 or 40, you can see that there are just billions of gallons that are not being managed the way we would prefer them to be.
Jim, I'm sorry, it's Melissa, 5 minutes.
Okay, I'm closing her up. The other thing to think about is roofs. This happens to be a cistern on a Target store, and this Target store happens to be built on top of a landfill, a covered landfill, so that infiltration down is not particularly good, but it is managed so the water off the roof is captured. It is used to water the plants around the building and substantially reduce the amount of flow that leaves the building. These sorts of things can also generate very large numbers. So we all know that in the springtime our soils are mucky. You don't really want to walk across your lawn because it's filled with water. Well, that water, because it's moving slowly, is helping recharge the groundwater. That is good. Summer rainfalls, some will sink in, but because they come very rapidly, some will run off downhill, and less will be able to be recharged. And so as one thinks about climate change, they have to recognize that if we expect more peak flows, and we do, and we expect longer droughts, then our fractured hydrologic cycle will work worse than it does today. And this just reiterates that we are, in many ways, the places we've looked, we are lucky. The groundwater sources are quite high. They're quite permeable. But that does not mean that continued shortcutting of the water source will not cause problems in the water supply. Here are some numbers just to talk about the cost and some values, and these are round numbers. When talking about green infrastructure, I encourage municipalities to think about the total cost of green infrastructure. One of the reasons traditional civil engineers like gray pipes is you can build them and then ignore them for 50 years. Green infrastructure works better. It is cheaper to construct. It is cheaper to it's cheaper overall. However, you must budget for long-term maintenance if you want them to continue to operate properly and you want it to continue to be an asset to your community. So the summary is, learn from our past mistakes. Baked into your codes, baked into your stormwater fees, baked into your sewage fees are a bunch of both financial incentives that prevent innovative use of green infrastructure and water efficiency and things like that. Those decisions made sense at one time, but they make less sense today, and they're difficult to open, but they are, to encourage proper use of water, we need to revisit our codes and fees. The integrated water system is very, very logical. It will reduce your costs in the long term, but you must recognize that there's just a number of people that have to be brought into the loop because of the many different groups that work within the hydrologic cycle, even within your own municipality. So if you're going to do integrated water planning, you want to include a large number of departments. And if you plan to combine, water conservation and efficiency, it's a pretty logical conclusion. What you're really trying to do is you're trying to manage rainfall, snow melt, where it falls. You try to manage it as it flows towards a river, whether it's underground or overground, and you want to manage it before it is discharged to the river or lake. It's pretty straightforward. If you could do these things, not only would you expect improved ecological impacts, but societally you would as well. We have found that in communities that have embraced green infrastructure and smart water use, they are higher quality communities. And so I can present the numbers, just as Bill can present the numbers, that if done right, it's a lower long-term cost, which all communities are looking for, and your community will benefit. And with that, I'll turn it back over to John, I think.
Thank you, Jim. We're going to open up the question period right now. First, I think Laura was going to put up just our contact information first for the Greater Lakes project. If folks have any additional questions that you don't get answered on this call, please feel free to reach out to John Jackson. And then also my contact information at the Great Lakes and St. Lawrence Cities Initiative. If you visit our website as well, there'll be a link to this webinar and to others we have in this series. So at this point, I'd like to open up the questions. Laura, I guess first I'll ask, were there any questions written in on the chat section so far? Oh, Laura, I think you're muted.
Yes, we did have one. Excuse
okay.
me. This was from Bill's presentation from Jim Robinette, wondering if waste transport from house plumbing to sewer systems decreases when using low flush toilets.
Yes, if you reduce the water consumption of anything indoors, it will reduce the amount of water going into the sewage system. And one of the benefits of that, or two of the benefits really, because it's on the utility and customer side, is the sewage utility will have less flows, and the customer will save on their sewer bill.
Great, thank you. Laura, any additional chat questions at this point, or has anybody raised their hand?
We did have some hand raises earlier, so let me pull those up. We can open those lines. It looks like folks had their questions answered as we went through the presentations. Feel free to click the hand icon if you'd like to ask a question, and we'll open your line from there.
I guess this is Melissa. I'll just put a question out there for the team, and this may be a bit early, in the project as we're working to better understand, how we can help municipalities, move the bar on integrated water management. But just some preliminary thoughts from folks on, what are some first steps? Like I know, John, there was that workshop that you guys had in Guelph, and I think, there was some eye-opening, some epiphanies from that workshop when folks all got into the same room together. So I'm just curious, what are some first steps that folks on the line could start thinking about if they're going to go back to their municipality and try and work on moving the bar on integrated water management?
Well, it's John Jackson here, and I'll speak first on the workshop you just referred to, which I think was very valuable. And we held this in Guelph 2 weeks ago. And what we did, we pulled together people from the various departments. The people you normally think of in terms of the engineering departments and so on, and the water supply departments, but also pulled together the planning department, the finance department, because they're the ones always watching the dollars spent and so on. And we spent about 2/3 of a day with, first of all, a couple of presentations of people talking with their practical experiences about how they've been dealing with water efficiency and with green infrastructure. But most of it was talking back and forth across the table. There were about 30 people there, and having a real in-depth discussion of how they're affecting each other, of ideas coming out from them, of how they could make sure they were better communicating and working together in the future. and a really strong recognition by the people of their need to make sure that when they were planning, for example, in terms of future infrastructure, et cetera, and when they were planning in terms of developments, particular development proposals and so on, that they need to have all their departments together, talking about them at once to come out with the best solutions. It doesn't mean that they each then implement it all. I mean, that's up to each department to do, but to make sure that they're working towards common purpose. So just getting together for that time was a really valuable thing. I've already heard back from people there who are talking now about follow-up meetings with their fellow departments to talk in some more specific questions.
Great, thank you, John. Bill or Jim, anything to add?
I would suggest municipalities also look at other municipalities, either through trade groups that are kind of further along, to try not to avoid, try to make new mistakes, not the same ones before. You know, I referred several times about codes and why that's important. When we first started trying to build green infrastructure, and this is before it was even called green infrastructure, we found that built into the codes, it was all but impossible. New subdivisions in several counties in southeast Michigan required that you build your roads to a Michigan Department of Transportation standard, which, I don't know, made sense, I guess, other than I had one water resources commissioner call it, you were building parking for the 1-in-100-year party. And so you had all these excess lanes draining 2 pipes that, frankly, the developer didn't want to put in. So the first thing you had to do is get the code to allow that, and then try to encourage them to use smarter things. And lastly, many municipalities are thinking about how to pay for stormwater. And to date, stormwater has been buried either in property, it's been buried all over the place. It looks free to the property owner. And so as either stormwater fees or stormwater utilities are coming into place, they should be put in a position where, yes, you get an advantage if there's more pervious area than impervious, and that's usually standard. And there should be a financial advantage to the property owner when that happens. But I would argue you'd want even more financial advantage if there was storage and they sort of kept some portion of the peak flow at their property for some period of time. And lastly, there are means of coming to very near zero discharge, and if there's a financial benefit to allow them to do that, people will strive for that. And so, once again, review what other people have done, review your existing codes for things that are baked in that make no sense, and review if your fee structure, both your water supply fee, your sewage disposal fee, and your stormwater fees are not supporting integrated management.
Great, thank you, Jim. Well, I recognize we're at the top of the hour, but certainly if there are any more questions, we can stay on the line to field them. Laura, were there any additional questions?
Yes, we do have one more chat question. This is to Jim, wondering if cities are building low-impact design facilities internally, or if most LID facilities are being designed through consultants and then built through on-site contractors. And then the second part of this question is wondering what the cost was of the median LID facility that replaced 2 lanes.
It's all of the above, but we have something that's unique in Michigan called a drain commissioner, and they have the ability basically to charge for drainage. And it's an old law, and it was for draining farms. But the really progressive ones, and the one of in particular in Ingham County, first began, putting in green infrastructure, once again, long before it was called green infrastructure, to solve both his sewage capacity problems and his flooding problems. And he built some major green infrastructure facilities. And when he began his maintenance staff hated it, and his design staff hated it because it was different what they were. But with time, oddly, they figured it out, and now they're very strong supporters. And so what I have seen with all types of stormwater management is you begin by having an internal champion, and that internal champion can build internal capacity. But that internal capacity, the hardest part is retraining the folks that are already on board. Most of them will go along pretty well because, frankly, it's more fun than putting pipes in the ground. But it does change. It requires a change in how you view your job.
Great, thank you, Jim. Any additional questions at this point?
I think there was a second part to that last question that was about cost.
Right.
When you took out the 2 lanes.
Yes, that's correct.
Can you repeat that for Jim?
Sure. I was wondering what the cost of the median LID facility was that replaced the 2 lanes.
I can give you that cost, but not off the top of my head. I will say, just as Bill has the drinking water end of efficiency, there are some pretty sophisticated spreadsheet models that give you some round costs for those sorts of things. Not that specific thing, but what they have found in some places is once you decide how much water you need to capture and get out of downstream, then you need to prioritize your cost per dollar per gallon removed, and then decide what mix of green infrastructure solutions will get you to that target fastest. So there are municipalities that have really started to put the arithmetic down to the capital and operating costs for those sorts of things. I can get the answer to that specific question, but not right this second.
Maybe we'll hold on to the name of that person that submitted that question, Laura, and we'll put him in touch with Jim after.
Sounds good.
Via email, perhaps. Okay. Any additional questions? With none at this point, again, actually, Laura, if you could just put up our contact information again. If folks, think of anything else, please feel free to email either myself or Jim or John. I'm sorry. I wanted to just put a plug in for the next webinar of the series, which will happen on April 1st. It's another Wednesday. This will be a more in-depth discussion on integrated water management, and this webinar is geared towards our municipal partners. We'd like to have a very focused discussion with folks to try and get a better sense of, what some of the challenges or barriers may be that cities are experiencing as they work on integrated water management, and try and get a better sense of what they might need to help advance it. So we encourage cities to participate on this call, as it's going to help guide our work over the next 9 months, on the rest of this project. With that, I'll just ask John, did you have anything else you wanted to add?
No, just to really thank you for pulling this together, and really appreciate all the people being on the call, because this is such an important topic, and I think people are doing so much on it, but we need to make sure that we're sharing with each other what we're learning as we do this.
Great, thank you. Well, thank you for joining us. Hope to see many of the folks on the next webinar, and we'll be sending out an announcement for subsequent webinars in the series shortly. Thank you.